Hello, welcome to PhyzQuest. This video is about the solution of JEST 2019 Part A, question number 4. So here the question is, consider the following transformation of the phase space coordinates small q small p to capital Q capital P. Now here the relationship are given as the capital Q is equal to q to the power a cos bp and capital P is equal to q to the power a sin bp. So for what values of a and b, the transformation will be canonical? 4 options are given and we need to find out the correct options. Now here the question is based on classical mechanics. The concept involved here is canonical transformation. So let us first understand what is the canonical transformation. Just consider a simple example. Consider a particle moving on a surface, any kind of a surface. So, suppose you need to define the position of the particle. So, how do you define that the position of the particle? You can express the position in terms of Cartesian coordinate xy. Now, there is another way as well. You can also use plane polar coordinates r and theta to describe the same thing. So basically here the particle is one, but the representation are different. So here xy is one set of coordinates and r theta is another set of coordinates. So here the process of transforming one set of variable to another is called this canonical transformation. So canonical transformation is transformation of one set of generalized coordinate to another set of generalized coordinate. Now how to check that whether the given coordinate transformation is canonical? There are different ways, but the easiest way is the method of Poisson's bracket. Now there is another method, that is Lovelace's differential form, but Poisson's bracket is the most convenient one. So suppose there are two set of coordinates. The old set of coordinates is small p small q and the new set of coordinate is capital P capital Q. So the condition that the transformation from small p to small q to capital P capital Q will be, to be canonical, will be the Poisson's bracket of capital P and capital Q is equal to 1. Now here in examination, when we come across this type of questions like about one canonical transformation, basically there will be two categories. Either you have to check whether the transformation is canonical, or in the relationship given there will be certain constant involved and you need to find out the condition at which the transformation would be canonical. So this is the second category type of question. Here the relationships are given and we need to find out the condition at which the transformation would be canonical. So here the new set of coordinate is capital Q and capital P. Now here in this question the relationship are given as the capital Q capital P are new set of coordinates. So capital Q is equal to q to the power a cos bp and capital P is equal to q to the power a sin bp. So we need to find out for what values of a and b the transformation is canonical. That means for what, as I said, the condition to check the canonical transformation is Poisson's bracket of the new set of coordinates should be 1. So that means we need to find out for what values of a and b the Poisson's bracket of q and p will be 1. So let's check that. So as I said, the condition is the Poisson's bracket of qp equal to 1. So just expand it, which will be del capital Q by del small q into del capital P by del small p minus del capital Q by del capital P, small p into del capital P by del small q is equal to 1. So now we have to individually find out, take the partial derivative of each of them. So del capital Q by del small q will be, this will be when we carry out the partial derivative of this with respect to small q, only differentiation will take place for this. So it will be a q to the power a minus 1, cos bp will remain same. So second term will be, it will be with respect to small p, so this term will change. So this will be q to the power a b cos bp. So ultimately this we can write, for this it will be a q to the power a minus 1 cos bp. This will be q to the power a b cos bp plus q to the power a b sin bp. The minus sign will be gone because when you take the differentiation of this, it will be minus sin bp. So minus minus will be plus. So q to the power a b sin bp into a q to the power a minus 1 sin bp is equal to 1. Now when you multiply everything, this is one set of multiplication, this is another set of multiplication. So first consider the power of q. So here q to the power a minus 1, here we have q to the power a. So ultimately it will be q to the power 2a minus 1, and that is a and b, and both the terms have cos bp. So it will be, and in this case q to the power a, q to the power a minus 1, same, it is q to the power 2a minus 1 into ab, and here we have sin square bp. So this we can write ab q to the power 2a minus 1 cos square bp plus ab q to the power 2a minus 1 sin square bp is equal to 1. Now in this case, here both the terms have a b q to the power 2a minus 1. So you can take common this term. When you take common a b q to the power 2a minus 1, the bracketed term will be cos square bp plus sin square bp. Now you know that cos square theta plus sin square theta is equal to 1. So this term will be 1. So ultimately we will have ab q to the power 2a minus 1 is equal to 1. Now 1 we can write as 1 into q to the power 0. So we have to compare this term, this expression with this expression. So that means from this expression what we have got, that is ab is equal to 1 and 2a minus 1 equal to 0. So when 2a minus 1 equal to 0, it will give a is equal to 1 by 2. And second relationship we have got ab equal to 1. We have already calculated a as half. So ab will be equal to 1 only when b is equal to 2. So we have found out the constant values where a is equal to half and b is equal to 2. So now let's check the options. So options here are, option A says 1 1, option B is half half, option C is 2 and half, and option D is half and 2. Here we have got the values of A as half and B as 2. So option D is matching with our calculation. So the correct answer for this question is option D. Thank you.